Welcome friends, in this video we're going to learn how to find some basic areas. So here I have some shapes. Got a triangle, a shape that looks like this, and a shape that looks like this. And I want to be able to find these areas in a way that's easy. So in other words, I don't want to have to deal with these complicated shapes. Is it possible to do so? Well, of course the answer is yes. Let's take a look. So I'm going to cut these out. Take a look here. So the first shape is a basic triangle. I'm just going to cut it out. And the idea is simple. Begin with a triangle. We don't want to deal with a triangle, so instead we just turn it into a rectangle by cutting it this way. And then you just reassemble the pieces together and that's it. So for example like this, you see? When you do that, that just gives back a rectangle. And here a rectangle is easily found. It's just the base times the height and that's it. You can even see a little bit through this paper here to see that it completes the squares on the other side. So then you know it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 squares. So 3 on the bottom, 1, 2, 3, 4, 5 this way, so 15 squares. So for example, let me see here. Each one, as you can see, is about half an inch. So then, for example, to find the area in terms of inches squared, you just take 1, 2, 3, 4, 15 that is, and multiply by the fact that each little square here is about half an inch by half an inch. I don't want to carry, out the math, that's not important. The point is to understand you can take a triangle and turn it into a rectangle to find the area more easily. So that's one thing. Let's take a look at these here. So here I have a parallelogram, this shape right here. I'm just going to cut it out quickly. Here's my parallelogram. I'm going to apply the same principle. Again, I don't want to deal, for example, with a shape like this. So instead I just trim this. Take a look. And I move this portion that I've trimmed over here. And you see how again it completes a rectangle in this position. Now again we have a rectangle. So we have a 3 this way. 1, 2, 3, 4, 5, 6 this time. So 18 little boxes is the area of the rectangle. Remember, the way I measured it, at least each one was what there? About half an inch per box. And this dimension and in this dimension also. Half an inch by half an inch. So you could find the area of one little square in inches squared, and then, for example, multiply by 18. But again, the big idea is you can turn basically a parallelogram into a rectangle, so you can find the area more easily. The other thing is this actually gives us another aspect to it. Take a look. What if this is the original shape right here? Look. This is basically like a trapezoid, right? Imagine you begin with this shape instead. It's a trapezoid. We can apply the same principle, namely, just trim this off, move it over here. It is the same rectangle as for the parallelogram. That's it. So you can find the area the same way after that once you move it here. So that's a simplification. Let's do one last one here. So here's my last shape, and I'm going to repeat the same process. Again, finding the area of this directly might be a bit tricky. But you can tell obviously that if I simply fold it in half, for example, I can do this in a variety of ways. In fact, take a look. I can just cut it down the middle. That's a place to begin. And now I form, take a look, right? A rectangle this way. And then after that, I can obviously just take a look, trim this away. Let me see here. I can position this over here. And now I have basically a nice rectangle. I can count the boxes. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This way and 2 across. Well, 2 vertically across. So I know this consists of 24 little boxes. And I know the area of each box, so I can just multiply by 24. The mathematical detail is not important, right? What matters is understanding you can convert many seemingly different shapes into a rectangle. You can find the area more easily.